Okay, so last time we were looking at hash tables, and today we'll go over an application of hash tables that will be actually one of your assignment, it's second assignment. Okay. Alright, so the problem here is given an array of unique integers, what we want to find is contiguous subsequences of length 2 or more, as well as find the length of the largest subsequence. So like you see, this is a given array 36, 41 and so on, also here written here. So these are the subsequences of length 2 or more. Okay. Also I print the length of subsequence 1, but these are the really subsequences we're interested at. And we want to really find the length of the largest subsequence, which is 5. Okay. This is what we want to do in this problem. Given an array of unique integers, what's the length of the largest subsequence of length 2 or more? Now, what we are going to go discuss in this lecture is thus assuming the array has unique integers. In your assignment, you will modify this algorithm to be able to run for arrays that may not have unique integers, in the sense that the array may have element appearing more than once, and still you should be able to find larger subsequence of length 2 or more. Okay, so that's what you'll do in your assignment. Okay. So it just needs a small modification, some additional memory and all those stuff that you need to do for your assignment. So once you understand the logic you're going to now, it should be very easy to do the assignment. Alright, so okay, so we are going to use hash tables to store the elements in the array. So we can assume a hash function. So if I do not give you a hash function, you can assume 1. The only criteria is the divisor should be a prime integer. So we'll assume here there are 11 integers, so 7 is reasonably a good size for the hash table. So once you decide the divisor, size of the hash table gets fixed. So it is 7, so there are going to be 7 index entries in the hash table. So then you have to fill up the hash table first. So go through each element in the array, find the remainder and add them to the hash table. 36 mod 7 is 1, so 36 gets in the hash table at index 1. 41 mod 7 is 6, so 41 is here. 56 mod 7 is 0, so 56 is at index 0. 35 mod 7 is also 0, so 35 will be added to the list at index 0, and so on. So that's the first step, fill up the hash table based on the elements in the given array. So then what you do is go through the array one more time. So we went through it once to build the hash table. So again go through the array from index 0. So this is what I show here. So starting from 36. Now what we want to now find is the sequences of length 2 or more. Okay. Alright. So now if you think about this, for a sequence, it has to start from somewhere. So for example, the sequence I have shown here starts from 41, and all these elements from 41 to 44 are part of the given array. So when we look at an element in the array, we need to decide whether it is the first element of some subsequence. That's what we need to decide now. Okay. So we'll go through the array now from starting from left at index 0. So let us check if 36 is the first element of some subsequence. So how do we check for that? Now we know 36 is in the array because we are looking at the array and processing the elements. So there is no need to make sure 36 is in the array because it is there, right? So that's what we are looking at. So we need to check if an element before 36, again remember we're looking with integers. So the integer prior to 36 is 35. So we need to check whether 35 is part of this array. Why we need to do that? If 35 is part of this array, if there is some subsequence of the elements in the array, then 36 will not be the first element of such a subsequence, because if 35 is part of the array, in that subsequence, 35, if at all it's the first element in that subsequence, will be there, 35 followed by 36, and so on if there are some more, if 37 is also there. If 35 is not there in the array, then 36 would be the starting element of subsequence, right? So that's why we check for any element in the array. We need to first check the element one less than that is there in the array. Okay, so let us do that. 35 is the element one less than 36. So how to check 35 is there in the array? Find the hash value of 35. 35 mod 7 is 0. So index it to cell 0 of the hash table. We have this linked list, and check if 35 is there in this linked list. If 35 is in this linked list, then 35 is in the array. That's why we build the hash table, to check if any element in the array is really there. So 35 is there in the array. That means 36 cannot be the first element of some subsequence, the starting element of some subsequence, because 35 is there. So in that case, we don't need to do anything with 36 anymore, because it cannot be a starting element of some subsequence. Just go to the next element in the array. In this case, we have 41. So to check if 41 is a starting element of some subsequence, we need to check if 40 is there. Sorry, I said 37 or something. So to check 41 is a starting element of some subsequence, we need to check if 40 is there in the array. So how do we do that? Find 40 mod 7, it is 5. So index into cell 5 and see if 40 is there in the linked list there. 40 is not there. So that means since 40 is not there, 41 is a starting element of some subsequence. Okay. So now we need to continue further and check if, since 41 we decided to be a starting element of some subsequence, we need to check for subsequent elements. So let us check for 42. How do we do? Again, just find the reminder, 42 mod 7 is 0, 42 is there. So it's in the hash table, so it should be in the array. Check for 43. 43 mod 7 is 1, 43 is there. 44 mod 7 is 2, is also there. Now check for 45. 45 mod 7 is 3, and 45 is not there at index 3. So that means we should stop. So the subsequence started with 41 and ended with 44. So 45 is not there. So even if 46 is there, we cannot say it is part of this subsequence. Okay. So then move on to the next element, 56. To check if 56 is the starting element of a subsequence, check for it. Find if 55 is there in the array. 55 mod 7 is 6. It's not there. So that means 56 is the starting element of some subsequence. Now check for 57. 57 mod 7 is 1. 57 is not there at index 1. So 56 is by itself a subsequence of length 1. Even though we are not interested in such subsequences, as part of the algorithm, we will end up also finding such subsequences of length 1, even though we are interested only in subsequences of length 2 or more. So now we are at 35. To check if 35 is the starting element of subsequence, check for 34 in the array. 34 mod 7 is 6. 34 is there at index 6. So 35 cannot be the first element of some subsequence. So we're done with 35 with that. Check for 44. So to check if 44 is starting element, check for 43. 43 is there in the array. So we don't need to do anything at 44. So like that, keep moving. So now let us see 92. 92 to be a starting element, we should check for 91 in the hash table. 91 mod 7 is 0, and 91 is not there in at index 0. So 92 is a starting element of some subsequence. So now check for element greater than 92, which is 93. 93 mod 7 is 2, which is not there. So that means 92 again by itself is some subsequence of length 1. Now 43 to be the starting element, 42 should not be there. Check 42 mod 7 is 0, 42 is there at index 0. So since 42 is in the hash table, it is in the array, and 43 cannot be a starting element of a subsequence. Now for 32 to be a starting element, check for 31. 31 mod 7 is 3, and 31 is not there. So 32 is the starting element of a subsequence. Now check for 33. 33 mod 7 is 5. It's there at index 5. The link is there. So 33 is part of the array. Then check for 34. 34 mod 7 is 6 is there. So 34 is also part of subsequence. 35 is also there. What about 36? 36 mod 7 is 1. It is there. Then 37 mod 7 is 2. 37 is not in the hash table. So that means it's not part of the array, and we should stop the subsequence check there. And we can say 32 to 36 is a subsequence, and that's of length 5 greater than what we have found so far, which is 4. So that's how you kind of update the length of the longest subsequence. Now 42 to be the first element of subsequence. 41 should not be there. 41 mod 7 is 6. It's there. So we can stop with 42 there. It cannot be the starting element of a subsequence. So done with going through the array. So by the end of this, you should have found the longest subsequence. Any question on this logic so far before we look at the pseudocode and the time complexity?
Not yet.
Yes.
I said not yet. I don't have any questions yet.
Yeah, go ahead.
No, I don't have any questions
okay,
yet.
okay.
I want to see the pseudocode first.
Sure. Okay, so the pseudocode should be what I explained. Let us go through this. Please. So the first step is to insert the elements of the given array in a hash table, which you know how to do it. So go through the array, find the hash values, it is the reminder, and index into those cells and build the hash table. Then initialize our largest length variable to be 0, because that's the variable that we use to keep track of the length of the longest or largest subsequence. Then run a for loop to go through the array again. So index 0, 10, minus 1. Now as I said, a of I means the element at index I. We know it's there in the array, right? So we don't need to check for its existence in the hash table in the array. So what we'll do is we'll check for a of I minus 1. So if you say a of 0 is 36, it's the first element at index 0, we'll check for a of 0 minus 1, which is 35. So check if 35 is in the hash table. If 35 is in the hash table, then 36 will not be the first element of a subsequence. 35, if at all 34 is not there, will be the first element. So since 35 is there, 36 cannot be there as the first element, so we don't process anything further with 36. So that's why this if starts here with ai minus 1 not in the hash table. In this case, ai minus 1 is in the hash table, so we don't do anything else with this a of I. Continue to the next I is 1, so that is in this case 41. 41 minus 1, which is 40. Check if 40 is in the hash table. And how do we do that? Find the reminder, and 40 mod 7 is 5. Index into cell 5 and search for 40 in that list there, and it's not there. So since a of I minus 1 is not in the hash table, we will do the following things inside the loop. So what we do here is, since if 40 is not in the hash table, so 41 is the starting element of some subsequence. So now we need to check for elements greater than 41, like 42, 43 and so on. So we use a local variable j to be a of I, increment j. So j is like what, 41 initially, or j will be 42. So check for j, the latest value of j is 42, whether it's in the hash table or not. If in this case 42 is there, so we'll increment j. If j is not the hash table, we'll come out of this inner while loop. So if j is there, keep on incrementing j. So in this case 42 is there, 43 is there, 44 is there, but 45 is not there. So we'll come out of this inner while loop. Now j is 45, which is not the hash table, so that's why we came out. And the visibility of j is even outside the loop. You see we have initialized j before the loop, so you should be able to access the value of j after the loop. So j minus a of I, so in this case that will be 45 minus 41. And what does that give us? 45 minus 41 is 4. That gives us the length of that subsequence starting from 45 and ending before 45. So starting from 41 and ending before 45. So that's what 45 minus 41 gives us. It gives the length of the length of the subsequence starting from 44 and ending before 45. So we check whether what we have found is of length greater than 1, because we're interested in subsequences of length 2 or more. So the length 4 is greater than 1, so we can print all integers starting from a of I to j minus 1. So a of I is 41, j is 45, so 45 minus 1 is 44. So we'll print the integers from 41 to 44. And if the largest length we know so far, which is 0, is less than the length we have found now, which is 4, then we can update largest length to be that value, which is 4. Okay, so that's what we do if an element is a starting element. If an element is not a starting element, we just move on to the next element. So let us now look at 56. If 56 has to be a starting element of some subsequence, check for 55 if it's in the hash table. It's not there. So since 55 is not in the hash table, we come inside this loop, assign j to be say 56, j equals j plus 1, which is 57. Check whether 57 is in the hash table. It's not there. So that means we don't go inside the while loop. We come out and j is 57 minus 56 is 1. So 1 is not greater than 1. So we don't even go inside the if block. So this output 56 should not be printed. I am just printing it to show that with this logic we could even find subsequences of just even length 1. Okay. Then move on to the next integer, which is 35. So a of I minus 1, 34 is in the hash table. So we don't do anything with that. So keep doing like that for all the subsequences. So in the case of 32, 32 minus 1 is not there. So we get inside the loop and set 32 to j to be 32. Then j equals j plus 1. So j is 33. Check if 33 is in the hash table. Yes. Then 34, 35, 36, then 37. It's not in the hash table. So you come out of the j loop. So when you come out of the j loop, j is 37, a of I is 32. So 37 minus 32 is greater than 1. So we get inside and print all integers from 32 to 37 minus 1. So 32 to 36, 5 integers. So the largest length that we know so far is 4, is less than 37 minus 32, which is 5. Yes, 4 is less than 5. So we update largest length to be 5. So until we process 32, 4 is the length of the largest subsequence we know so far. So now we process this 32, and this is the starting subsequence starting from 32. We see that subsequence of length 5, so we update the largest length to be 5 instead of 4. Okay, is there any question now on this logic, how to do this? So for an assignment, what you need to do is modify this algorithm to be able to handle arrays that may not have unique integers. Some integers may be repeated, and still you should be able to print the length of the largest subsequence or length of all the subsequences. Now in the subsequence, the integers should appear only once. So you should not, if 32 is there multiple times, you should not include 32 all those times in the as part of the subsequence. Only once should be considered. Okay. So let us do the time complexity analysis. So if you look at the pseudocode, the key thing, the basic operation that we do repeatedly is we need to check if some element is in the hash table or not, a of I minus 1. Again, we need to check if j is in the hash table. So we do a comparison here, but we don't do that many times compared to the process of checking whether some element is a hash table, and that's more time consuming than doing comparison. So doing what is called a hash search is the basic operation. Checking for some element whether it's in a hash table or not can be called as a hash search operation. So what we need to find out is how many times we do this hash search. Okay. Now if you think about the logic that we followed, we first go through the array once and build the hash table that we have to do anyway. So then according to this logic we check if a of I minus 1 is in the hash table or not. So for every element a of I, we check if a of I minus 1 is in the hash table. So the elements I have written in blue are the ones that are in the array, and 1 less than these values are what is written in red. So for every blue element out there, we check if a red integer 1 less than that is there in the array hash table or not. So that's one hash search for each of those values. So if you have n integers, you do n hash searches with these red integers, which are 1 less than the elements that are in the array. So then to find subsequences of length 1 or more, basically you need to check if the subsequent elements after the element in the array, after a of I, that's why we initialize j to be a of I, we need to check if the subsequent elements starting from j plus 1 are in the array or not. So in the case of 41, we check for 42, 43, 44 until 45. And in the case of 56, we check for 57 and so on. So those I have written in black. So if you now sum up the count the number of black colored integers we have here, that will also add up to the number of elements in the array. Okay. So basically you can check the elements we're checking. 42 is in the array, so that's counted once. 43 is there, 44 is there, 45 is not there, but that will be counted as part of, like, see, 45 minus 41, right? So that's 4. So that means we are checking for the existence of 4 of these elements in this hash table. So that will add up to that number. So 57 is not in the hash table, but 57 minus 56 is 1. So that will be considered as one count, one hash search. So if you count the number of integers that are colored black here, that will add up to n, the number of integers, and the ones that are in red will also add up to n, the number of integers. So these n plus n, 2n is the number of hash searches we are doing for this problem, and 2n is that of n. Okay. So I have written here the first n correspond to the sum of the lengths of contiguous subsequences, and second n is the sum of all the ones, one for each element in the array. Okay. Any question on the time complexity? Okay, so let us stop.